Hey everyone, Joel here. This is the fifth video of this Autograd series. And before we get into building a neural network, which is I think where we're going to go today, I had a clever idea that I wanted to do. And that's as follows. If you remember last time we did these in-place operations where, in-place add, we actually replaced the data attribute. And then when we did that, we had to invalidate the gradient, or remember to invalidate the gradient. Because once you modify the data manually like that, the gradient is no longer valid. So what I was thinking is as follows, and this might be a good idea, this might not be a good idea, is that now instead of having data be accessible like that, I'll stick it in this underscore data. So you wouldn't dot into it. And now I'll use Python's property stuff. So, if I do data self, and that will return a NumPy array, because the data is a NumPy array, and I will just return self.data, which is fine. And now, this is a clever trick that I actually just learned by looking it up. If I do data.setter, that will do a setter for this, and I can do self and some value, which is a NumPy array, and it will return none. And we'll do two things. One is self.data equals, well, let me call this new data. Self.data equals new data, and setting the data manually means we invalidate the gradient. So I can do self.grad equals none. So now, if I go down here, I shouldn't have to invalidate the gradient because that will happen automatically when I set self.data. And that way, so one, I've saved myself some trouble. And the next thing is I've made sure that if someone else is using this library and goes in and actually starts messing with the data attribute of a tensor, then their gradients will get invalidated as well, as they should. So with that change, all my PyTests still pass. So I think that means it's a good change. So that's fantastic. And now what I want to do is I have this minimize a function. So I'm going to do, I don't want to do it there. I want to do it top level, add a file, and I'll call this simple neural net. And so I'm not sure that we've done enough in order to implement a neural net yet, but we'll find out what we're missing. And we're actually not going to do, let me not call this a neural net. I'll call this rename. I'll call this simple learned function, because it's not actually going to be a neural net. It's going to be a learned function. It's just going to be a linear model. So, I want to import NumPy as, I hate that autocomplete, and from autograd.tensor, import tensor. And I think that's it. So we want to generate some data. So, we'll just say x data equals a NumPy dot random normals, and let's make it 100 by 3, say. And let's say our actual coefficients are NumPy.array, and let's say -1 plus 3 minus 2. And so we can say y data equals x data matrix multiplied. So 100 by 3 times 3 comma will be 100, so that's fine. X data at coefficients, and then let's add a plus 5. So we have some parameters that we want to learn that are, y is x0 times minus 1 plus x1 times plus 3, whatever. And let's add some randomness here, so it's not fully linear. You know, np.random.rand int, let's say minus 5 to 5. That's too much. Minus 2 to 2, and size equals 100. So that let's see if that works. IPython run. What did I call that? Simple learn function. So x data is a bunch of stuff. Y data is a bunch of stuff, and that's perfect. So now what do I want to do? How would I learn this function, right? And so I need I'll call W, which is going to be my coefficients, is going to be a tensor, and let's just give it some random numbers. np.random.randn of, let's say, 3. So it's going to be a 3 tensor of random numbers, and B will also be a tensor. np.random.randn. What happened? Does that work right? Import numpy as np, np.random.randn. Yeah. So that will give me just a zero-dimensional tensor, which is also what I want. And I want these both to require grad equals true and requires grad equals true. So that's good. And so what do I want to do? For, let's see, epoch in range 100. Let's see, w.0 grad, b.0 grad. So one thing I would like to do is I would like to, and actually, x data needs to be a tensor, so let me do that. And similarly, y data needs to be a tensor, so let me do that as well. Okay, so I want everything to be tensors. So this is kind of yucky, but that's fine. And so, I have w0 grad, b.0 grad. And now, ideally, I would like to split this x data into chunks and operate on batches instead of operating on the same data set. In order to do that, I would like to do something like inputs equals x data, say up to 20. The problem is that we have not implemented this slicing yet. So we'll punt on that for now, to do implement batching. So for now, we'll just work on the whole data set, which is fine. So we want to make some predictions. So we'll say predicted is x data at w plus b, right? And then actuals is just y data, so that means that the errors is predicted minus actual, except I didn't call it actual, it's called y data, squared, and then loss equals errors times errors dot sum, and then this is very similar to what we did to minimize, to minimize the sum of squares function, except now we're minimizing these parameters, and so we'll say, w minus equals w dot grad times 0.1, and b minus equals b dot grad times 0.1, and then let's print the epoch and the loss. So let's see if that works. It may work, it may not work. Object arrays are not currently supported. Okay, that's Okay, so let's make this make that a tensor. Unsupported operand types for and at, tensor, and tensor. Okay, good. So this is saying that we need to implement matrix multiplication for our tensor. Matrix multiplication. And then the other thing, so this should work if we do, so let's do the matrix multiplication first. That's what's really stopping this from working. So, you know, again, we'll just do matmul t1.tensor, t2.tensor. Tensor, so this is easier in that we're not going to have to worry about the broadcasting, and it's harder in that the logic for doing the backwards propagation is slightly trickier. So what's something that I can copy? Let's take the multiplication because that's probably the closest. Is that all multiplication? Is all multiplication. Okay. So let's go through and say, now we want to matrix multiply. To get the data, we'll just matrix multiply the data. That's easier. Requires grad equals t1 requires grad or t2 dot requires grad. That's pretty simple. And so now, this is, if you watched the Livecoding deep learning library, this was kind of the voodoo part as well. But the key observation is that, if T3 equals T1 at T2, and grad 3 is, the gradient of some function with respect to T3, then grad 1, which is the gradient with respect to T1, is just grad at T2 transpose, and grad 2 is T1 dot transpose at grad. So if you think about it, when we had the similar thing where it wasn't matrix multiplication, it was just component multiplication, we had something similar, right? When I wanted the gradient with respect to T1, I just took T2 and multiplied it by the gradient. And similarly, when I wanted the gradient with respect to T2, I just took T1 and multiplied it by the gradient. Here I have a matrix multiplication, and it turns out if you just sit down and do the algebra, it's not complicated, but it's mildly tedious, that you have to transpose to make the shapes work out. And just to motivate that might be good, if T1 is N1 by M1 and T2 is necessarily M1 by M2, because if you want to do that multiplication, they have to have the same, inner shape. Then T1 at T2 is N1 by M2. So, grad 3 has to have the same shape as T3 is N1, M2. And so if I do grad 3 here, and I want to multiply it by T2 transpose, that will be M2, M1, and I get something that's N1, M1, just like T1. If I do T1 transpose, that'll be M1, N1, and I add it with N1, M2, I'll get N1, M2, which is the right, so the shapes are correct, so that should at least give you some confidence that it's doing the right thing. And so this will actually be pretty easy. All I need to do is say this is at T1.data.transpose, and because there's no broadcasting going on, I don't even need to do any of this stuff. In fact, I can just do that. And similarly, I can just, return t1.data.t at grad, and that should be good enough. So that one's pretty easy. And we should do a couple things now. We should go and add it as a dunder method to our tensors. So let's just go here and say, def matmul self other goes to be a tensor. Ideally, we check for the type, but but here I'll just do matmul self other. And I won't do ensure tensor because you shouldn't call matrix multiplication with something that's not a tensor. We like to discourage that. So I'm just going to leave that like that. And I should write some tests, but before I do that, let's just see if this works. And the problem is it's not doing my imports again. So let's just say Python simple learn function.py. So it's against the same problem where I tried to do t1.data.t at grad. Object arrays are not currently supported, right? So that's the same error I got before, and running a test would have caught that. And so the idea is that, what is the idea? Grad is a numpy array, t2.data is a numpy array, so that should be fine. And then similarly, grad is a numpy array, t2.data is a numpy array. So that should be okay, actually. So let me let's figure out what I did wrong, because I did something wrong. So when I do backwards, okay, well, let's solve it by writing a test. I tried to avoid it, and I failed to avoid it. So test tensor matmul.py. So let me just copy one of these, and I'll just deal with one simple case, and test tensor matmul, test simple matmul. Okay, so now we need things that can actually be multiplied. So let's do 1, 2, 3, 4, 5, 6. Okay, so that's going to be a I can't do matrix multiplication without writing out the shapes. T1 is a 3 by 2, and let's say T2 is a 2 by 1. So that will be, or actually, it's not a 2 by 1, it's a 1 by 2. So 10, comma, 20. Okay, so now it's 2 by 1, so it's 2 rows, 1 column, so that's good. T3 equals T1 at T2, so that's good. And now, we want to do the matrix multiplication, which once I multiply it out, it will be a 3 by 1, so I can figure this out. It's going to be 1 times 10 plus 2 times 20 is 50, and then 3 times 10 is 30, plus 4 times 20 is 80, is 110, and then 5 times 10 is 50, plus 6 times 20, that should be 170. And let me just delete the rest of this and make sure that that test passes. Okay, good, so that test passes. And let me undo the delete because I had some stuff that I wanted. And so now let's do T3 backwards. And I'm going to need it to be the right shape. And let's say grad equals numpy dot, say grad equals tensor of -1, -2, and -3. And let's do T3 dot backward of grad. So that should be fine. And let's just try running that and see if it runs into a problem. So it might run into a problem immediately. No problem there. Okay, good. So what do I want t1.grad dot data to list equals, and I'll just do data, equals, so what should it be? It should be grad.data at t2.data.transpose. So that's what I think the formula is. And if I run that, value error, the truth value of an array, so that's fine. Assert numpy.testing. Let's just say assert array equal. I don't know why my autocomplete is not working, but it's not a good sign. Okay, so that actually worked. And similarly, let's make sure that t2.grad.data equals t1.data.transpose at grad data. So if this works, then I'm not entirely sure why the other one failed. But that'll be an interesting. Okay, so this works too. So it seems to be doing the right thing here. And so I did something wrong, and let's try to figure out what it is. So when I run this script that I wrote, tensor.py line 263, it's getting something that's not the right type. So grad function 2, grad.np array, t1.data. Okay, so print grad, print t1, print t1.data, print t1.data.t, t1.data.t, and one of these is going to be way too big, but we'll see what happens. Okay, so t1.data.t certainly looks like an array. T1.data certainly looks like an array. Okay. Let me do the following, because this is what it's complaining about. So let me do the type of this and the type of this. And I should just use the debugger. t1.data.t and grad is a numpy array as well. So type error object arrays are not currently supported. Okay, so what that means is that it's an array, but it's an array of the wrong type. So let's print the D type. That could be interesting. And one of these things has the wrong thing in it. Both of these things have the wrong thing in it. Okay, so is it as simple as saying D type equals np dot float? Is that right? Let's try that again. Object arrays are not currently supported. Okay. You know, this is always fun. So let's print grad. So let's do that and just print the grad and see what it looks like. So that has a bunch of tensors in it. Okay, so that's definitely a problem. Okay, good. So now we're getting closer. So the gradient has a bunch of tensors in it. So let's go figure out why that is. If we go to simple learned function, loss equals errors and errors times sum. And so let's just print the loss and see what that looks like. The loss is a tensor with a tensor inside it. So I've done something extremely wrong. So let's make sure x is a tensor, coefficients is a tensor, and now what I've done is I've x data at coefficients plus 5 plus, okay, so this is probably my problem, that I wrapped this all in a tensor when x was already a tensor, so I didn't need to do that. Okay, perfect. And so now it's, the only thing is my loss is getting huge. So maybe I need to use a smaller learning rate. Let's just put it in one place so that I can do it in one place. Learning rate. And let's try it again. That's still really big, so let's make the learning rate even smaller. And so now the loss is getting about as small as it can. So I bet I don't have matplotlib, which is good because I don't know how to use matplotlib. So I won't be plotting this. So let's make this noise much. That won't work. I'll tell you what. Let's get rid of the noise. So now this should be a perfect linear function, and I should be able to learn it perfectly. And we'll see if because it's possible that 130 loss was actually the best I can do because of the noise. And you can see once I take out that noise, that it looks pretty good. And so, you know, if I look at the coefficients, -1, 3. Oh, whoops, that's what I started with. If I look at W is 1, 3 minus 2, and if I look at B is almost 5. So this worked to learn the coefficients, so you know I can get rid of that to do. I still need to implement the batching, and let me take a crack at that. So if I go to the tensor and I want to slice it, I'm just going to you know, def slice. Actually, I'll just this one. Yeah, you know, I want to slice t, which is a tensor, and index, which is probably going to be a slice, I want to say, and I'm not good. Slice, start, stop, step. So, you know, x equals slice from 1 to 3 by 2. X dot start is 1. X dot stop is 3. X dot step is 2. And we're not going to allow steps. We're only going to allow starts and stops. And if I do x equals slice, I think like that, x dot stop is none. So that's fine. In fact, you know what? I don't think I even need to worry about the slice. And so what is a slice? A slice is like when I do, you know, T2 equals T1. T1 3 to 4, and you can do a couple of them, right? So you can do it like that. And so this is actually it seems like it should be complicated, but I don't think it's complicated at all, because basically data is t dot data, and I'll do the same index, right? Requires grad equals t dot requires grad, and if requires grad, then depends on equals dependency t grad function, which I need to write. Otherwise, depends on is an empty thing, and return, a tensor with data requires grad and depends on. So I need to write the grad function. And our grad functions take grad, which is a numpy array, and they return a numpy array. And so the idea is that if I take just the first row, say, of a tensor, then I'm going to get a gradient back that looks just like the first row of the tensor. And only adjusting that first row will affect the output. Other rows, I've basically thrown them out, so they can't affect the gradient. So all I have to do is basically say, bigger grad equals numpy, zeros like data. So I want the zeros to look like the data, and then bigger grad index equals the grad you gave me. So you gave me a smaller piece, I'll set that, the rest can all be 0. And then return bigger grad. Okay, so the slice, and now we'll slice with, and I'll do it like this because you can specify multiple ones of them, right? And now what I can do, I think, is that if I go up and add a get item method, and I get some indexes, and that's going to get me a tensor. And all I need to do is just return underscore slice of self and indexes. So I would like to, I feel like this is using all my CPU, and that's why my autocomplete is not working. 448% CPU. That would explain why my autocomplete is not working. Which is fine, I'll just roll with it and not use autocomplete. So I want to test a slice. No, I don't need to test it. I should test a slice, but I'm not going to. So what I want to do here is now say batch size equals 32. And now what I want to do is I want to do for start in range 0, 100. I should add a length as well, but I know that I have 100. And then by batch size, and equals start plus batch size. And now what I can do is I can say inputs equals x data from start to end. And I'll move these above because they make a little bit more sense there. So now what I'm doing is instead of taking all 100 data points at once, I'm going to take only batches of 32, and then there'll be one that's smaller. And so now predicted equals inputs at w plus b, errors equals predicted, and so let's add another line. Actual equals y data from start to end, errors equals predicted minus actual. And so now let's say, epic loss equals 0.0, epic loss plus equals loss dot data, and I'll pull that out so that I'm not like keeping track of all these giant computational graphs. And then I print epic and epic loss. So if I do IPython and try and run it, name index is not defined, so that is why I should have written a test again. So let's see. See if that works. This lag from the recording studio is out of control. Where is that? 274. 274. Does it just not save? No, it didn't reload the module, which is why I need to do it. Okay, so that didn't work. So this is a little bit of a hack that means that multiple slices won't work. That will be okay for our purposes, but it's not ideal. I'm going to have to think about how to do that. Okay, so now you can see that I was able to do the batch size and things still worked. So that's good. So I did the batch size. So now this is starting to look like a pretty close to what our neural net library should look like. So what's less than ideal? One is we're going to need to do activation functions to do neural nets, and we don't have any of those here, so we can implement like a tanh, and that's not hard to do. Another thing is that having to define our model parameters like this is a little bit of a nuisance. Having tensor with requires grad, so we can probably take a shortcut there. And then the second is that to do all of this bookkeeping about remembering to zero out the gradients and remembering to update the parameters of the learning rate is also a nuisance, and it's fine when we have 2 parameters, but if we had a lot more parameters than that, it would become a bookkeeping nightmare. And so we need to, do something to take care of that. I think we will deal with that next time, and that might be the last one, unless I do something stupid on the end, which I am considering doing. Me, I like doing stupid things. So, thanks for watching. As always, can't even type my own name. You can find me on Twitter at Joel Grus, and make sure to tell your friends to watch these videos because they're pretty exciting, I think, as you can tell them. So let me find this recording thing and stop it. All right, thanks.